Hi, I'm Nick Parlante at Stanford University, and this is CS 101. CS 101 is about the basic features of how computers work. And I don't want you to think about the computer as some sort of magic box that you kind of interact with every day, but you're a little iffy about what's going on in there. Because really the basics of how computers work are understandable by anyone. So in CS 101, we're going to really look inside the computer and get a feel for how it works and indeed play a little bit with how computers work. And ultimately, I would like you to then understand what computers can do and what they can't do, how they fit into the world. I should say that no computer background at all is required for this course. This just assumes nothing beyond the ability to use a browser, and we're just going to work through it. So if you're curious about computers, this is a good next step. This is the right class. Just a brief format note. For every video segment like this, there's actually a companion written document with diagrams and explanations. And that's always going to be available for review. Even you could pause in the middle of the video and look at it, or maybe later, if you were curious about something, you could always go look at that as another way of getting the information. So I'm going to say that the fundamental equation of computers that has sort of their essence is that computers are both extremely powerful and profoundly stupid. They're powerful in that a computer can do billions of operations per second. It can just rip through data at just an inconceivable speed. That's the powerful part. But the computer is very stupid in that the operations that it can do so quickly are really very simple. So maybe add two numbers to get a third number, or check if a number is 0. So not only are those operations simple, but they're nothing like what you would describe as insight or understanding, right? Just add two numbers. Insight and understanding are really human qualities. And I want to highlight how the computer world is really this mechanical world, and then we'll connect how it is that you can make useful features out of that. I'll just mention in movies, computers they're never shown as mechanical, right? It's always essentially a human character that has emotions and gets mad or whatever. And here I have a link to the famous HAL 9000 video segment that represents that. So we've got this funny combination, powerful and stupid. And I got to say that it will come through very clearly in later sections when we start playing with computer code a little bit. You will get a vivid sense for that combination. But just for today, well, if the computer is so stupid, how is it that so many useful features can be implemented with computers? And in a way, that's what CS 101 is about. I want to visit the computer world and get a feel for this kind of powerful mechanical world of the computer. And then connect that to useful features that we use every day and sort of understand what puts all that together. Ultimately, the goal for this class is that you understand how computers work, and in particular, you're not intimidated, that you understand how they work and what they can do. Also, I'll mention here, I'll highlight my hidden agenda. Hidden agenda is that for some people taking this class, after we play around inside the world of the computer, some people may feel like, wow, that was pretty awesome. I really like computers. And so my hope is that those people would consider taking more classes in computer science. Certainly in the computer science department, it is thought that there are just not enough people in the world who are really comfortable doing things with computers. There are problems we would like solved with computers, and there's just not enough people to do it all. And so I'm always happy to get more people into the club. So at a high level, the operation of a computer is really driven by code. And for today, I'll just describe code as being made up as a series of instructions. So as I mentioned before, maybe add two numbers or something really simple like that. So here I have my little drawing. So inside the computer, we've got some body of code, and there's just a series of instructions. Oh, add these two numbers, and then compare this, and whatever. So what the computer does, really, is it just has the series of instructions, and it just does them in order. It does this one, and does this one, and does the third one, and the fourth one. So it just rips through them. When you hear the word run used with computers, that's what it means. There's a series of instructions in there, and it just rips through them. It just does them. And as before, yeah, it does them very quickly, but the individual instructions are quite simple. So I think this leads to a natural question of well, if these instructions are so simple, how is it that we can have a useful feature? So here I'm going to use red eye reduction. as an example of like, oh, that's a useful feature the computer can do. Or like, email or MP3 audio or, anything. So what connects these two sides? And the answer is, that's what computer programmers do. So a computer programmer maybe has an idea of like, oh yeah, red eye reduction, that's a great idea. We should have red eye reduction. And that's an insight. And then the computer programmer thinks of like, well, how could we do that? Well, we would look for the red color and maybe it's in a round shape or whatever. So think through how to do it. And then eventually, ultimately, the computer programmer has to break that algorithm down into simple instructions. In a way, sort of dumbing it down to instructions that are so simple that the computer can do it. And so whenever you've used email or SMS or whatever, some useful feature on the computer, it's because there was a person that had the insight like, oh, we should do that, and then the person structured it, sort of broke it down for the computer so that ultimately the computer could do it. And in a way, CS101 is gonna look at this picture, right? We're gonna examine the left. We're gonna look at what code looks like and what its limitations are and what it can do. And then I'm gonna want to formulate little computer programs that we can play with and that you can write to try and see both sides and sort of get a feel for how the whole picture works. I'm gonna say that I like this picture. I feel like it's a nice combination in that each side brings what it's good at. The computer programmer can concentrate on being creative and having insight and putting together, solving a real problem. And then, well, what is the computer good at? Well, the computer is good at being inexpensive, right? With Moore's law, which we'll study in a little bit, computers are just gradually getting cheaper. They can be more widespread, and the computer can be inexpensive and just rip through its instructions very quickly. And so that's great. Ultimately, that means we get, solutions to many, many problems, and they can be widespread. So that's fantastic. So in the next section, what I want to do is look a little more closely at code and get to a point where you can start playing with code.